My name is Elena Rekce. I'm in the interface between organoid biology and chemical biology. So chemical biology is how we can interfere with biological systems using small molecules, like aspirin is a small molecule, for example. And organoids, on the other hand, are three-dimensional cell culture models. So they're also termed mini organs. In my group, we work with mini organs from the gut, from the intestine. So we grow mini guts in the lab, but we also work on cancer. And what we're extremely interested about is to interfere with the metabolism of the cancer cells and of the intestinal organoids to learn more about metabolic flexibility as a whole, so in the gut and in the cancer. So metabolic flexibility is associated with resistance to therapy. So if we have a tumor that is very flexible, if there's, for example, chemotherapy, so normally this can only act when the tumor cell divides. But if there's a tumor cell that can just turn down the metabolism and stay quiescent under the surface, it can circumvent the treatment exposure and then reactivate the metabolism again and keep growing. And we want to tackle exactly the flexibility of the tumor to adapt to these changes. My research is very transdisciplinary because we are exactly at the interface of chemical biology and biology. So we want to, with this new model systems, this mini guts and the mini tumors, we want to look for tool compounds or new medicine using different methods to tackle, for example, on the one hand, then tumors, so to find new treatment approaches for tumors. And on the other hand, find small molecules that are helping to combat metabolic diseases in the intestine. So, for example, new approaches to tackle diabetes, for example. So for the tumor part, this has been shown already in literature by other researchers that the mini tumor from the patient reacts very similar to the patients in the clinic, to the donor, the original one. So with organoids, you can actually predict the treatment response of the patient in the clinic. And we hope that with basically having this tumor organoids in culture, we can also find more relevant medicine in future. So for the tumor part, it's definitely already evidence that this interdisciplinary approach finding drugs with the use of this new model system is much closer to the patient and beneficial. For the gut, there's less medicine that has been developed with organoids, so that's why we want to do that on the side as well. So we want to use these mini guts to find new treatment approaches for metabolic diseases, because we think that these mini organs are much closer also at the real system than all the models that have been used so far in the search for drugs looking at metabolism. I think the Agelander approach is for me especially very relevant because it is a professorship that was founded from the TRAS. And I think, especially when I was reading the job advertisement, the TRA was really appealing to me because this is exactly where I am. I'm exactly at the niche. So you have the zoology, the chemistry, like within the faculty of natural sciences. But with the TRA, you have everything in one. And this made it very attractive for me to apply. And also I feel very much at home with my research there because this is exactly where I am at the interface between different fields. And also the conjunction with the medical faculty also in the TRA Life and Health is really combining it all, because I have the chemistry that is basically next to TRA Meta. There's also the chemist, but there are some chemical biologists in TRA Life and Health, some from the medical faculty, some researchers, and at the same time also biomedicine as the Limes Institute, where I'm hosted at, where my group is situated. I think without excellence, you cannot get your research done. You cannot generate relevant results. So I think we all thrive for excellence when we are in research. I really like my team. I really like working with them. I think they're really dedicated. They really love their work. And it's quite challenging also to work with the system we're working with. So that means sometimes receiving patient material from the hospital, from a surgery that was in the afternoon, and then making the organoids. So you really need a very dedicated team and that are really excited about what they're doing. And I think I found such a good team. It took some time, so it took time to find the right people to share this excitement about my research, but I'm very happy with my team, definitely. And I think teamwork is everything in research, because without a team, without getting different expertises and different perspectives in, you cannot thrive for excellence without that.